Ready.
Can we start?
Yeah.
Okay. Thank you very much. Good afternoon to our attendees. Welcome to the second keynote lecture of the ERSA web conference today. My name is Georg Lohn. I am from the Institute of Economic Research of the Chamber of Commerce of Bolzano-Bozen. As a small local research institute in South Tyrol, we are engaged in applied economic research, especially on regional issues. The topic of transport and accessibility is of central importance for our region. South Tyrol lies in the heart of the Alps, and the central traffic axis between northern and southern Europe runs through our country. It's called Brenner Corridor, which is part of the Trans-European Transport Network. Currently, a new railroad tunnel, the Brenner-based tunnel, is being built under the Brenner Pass. With a length of about 60 kilometers, this tunnel will fundamentally change the railroad traffic between Italy and Central Europe in about the next 10 years. However, this new infrastructure will inevitably have a major impact on our small region. So what the Brenner-based tunnel is today was the introduction to the steam railroad 150 years ago. This revolutionized the transportation system of that time and led to the strengthening of the large cities and metropolises. And I'm therefore very happy that Professor Daniel Sturm from the LSE has agreed to speak on this topic, the making of the modern metropolis, evidence from London. Professor Sturm is Professor of Economics at the LSE and Research Fellow at the Center of Economic Policy Research. Currently, Professor Sturm is also President of the Urban Economics Association and holder of the Frisch Medal, an important award for econometricians. And now we are looking forward to Professor Sturm's presentation. And I would like to say, after the presentation, you can obviously ask questions. And please use the chat function for these questions. Thank you. Please, Professor Sturm.
Hi, welcome. My name is Daniel Sturm. It's great to see you all, if only just virtually. Let me share my screen here, and so that you can see my slides. So I hope slides are visible, and that's all fine. So I'm going to talk for about 30 to 40 minutes, and then there will be opportunity for questions right after that. So the paper that I'm going to talk about today is called The Making of the Modern Metropolis, Evidence from London. It's joint work with Stefan Hedlich, who's actually just changed location and is now at Toronto, with Stephen Redding at Princeton, and myself at the LSE. When I agreed to give this keynote, this paper was still in the publication process. It has recently been accepted by the Quarterly Journal of Economics. I apologize for presenting something that is already forthcoming at a journal. So the motivation for this paper is that we all know that modern metropolitan areas involve immense concentrations of population and economic activity. So one aspect of these metropolitan areas, certainly in the pre-COVID area, was commuting flows by millions of people every day. Of a large modern city is the constant backwards and forwards of commuters flowing from the periphery of the city to the center. So the question that we're going to ask in this paper is, in residence location play for our understanding of cities. So in particular, how does commuting shape the internal geography of cities? What is the sort of aggregate contribution of commuting to city growth and welfare? And sort of a more historical question is what and what made it possible. Okay, so that's okay. I'm back again. I hope you can hear me again. Sorry, the connection just crashed a second ago, and I'm going to share my screen again. Okay, Georg, can you see the screen again?
Yes,
okay.
Please.
Good. Okay, sorry for that. I hope this doesn't happen again. The wonders of modern technology. So the basic idea behind this paper is what we're going to do in this paper is we're going to study the how the invention of the steam railways and later on the electric railways have transformed the internal geography of London between 1801 and 1921. So why that period? So 1801 is the first year in which the UK has held a modern census. So it's the first year in which we have some hard data. And by 1921, much of the treatment effect has dissipated, and there's something very special in the 1921 census that I'll talk about in a second. The basic, in terms of timing, the first railway line in London opens in 1836, and the first underground line not that much later in 1863. So the basic idea behind this paper and the basic idea that we are studying is that trains, the invention of steam trains and later electric trains, obviously, or coal-powered trains, for the first time made it possible to have a large-scale separation of workplace and residence. I'll talk about some speed data later on, how much faster trains are than alternative forms of transport, such as walking. And we're going to see that the railways were a definite game changer. In the same way that, you know, a tunnel through the Alps could be a major game changer in terms of travel times today. What we're going to do in this paper is we're going to first provide some reduced form evidence for the impact of the railways on the geography of London. I'll show you some highlights of that in a moment. And then we're going to combine this reduced form evidence with a quantitative model of city structure. This model will allow us to, you know, we'll make additional assumptions, but it will allow us to get at some of the aggregate implications of this invention, the creation of the railways. Sort of implications such as how much did London grow because of this invention. Okay, so I'm going to skip the related literature in the interests of time and turn straight here to my outline for today. I'm going to talk very briefly about the data sources that we use in this paper. There's a lot of data. Then I'm going to show you some of the highlights of the reduced form evidence. Then I'm going to turn to the quantitative model. I'll give you sort of a flavor of what some of the key assumptions are, and then show you some of the highlights of the results, and then I'll have some conclusions. Okay, so let's turn to the data sources. The data sources here there's a lot of data, and a lot of data that we got from others when we're building, really standing here on the shoulders of giants in terms of a lot of work that has gone into the construction of this data. So first, we have population data, simple counts of population in 99 boroughs that are inside the modern Greater London area today, the Greater London, which is run by the Greater London Authority, the GLA. And we have created this data consistently from 1801 to 1921. We're building here on earlier concurrent work by a group of Cambridge economic historians who've done extensive work on the UK census data to make it easy to merge it into different geographies. Without that prior work, it would have been a lot of work to create this data. The second item is we have very detailed data on the transport network, which also comes from the same group of Cambridge economic historians. So we see for each segment of railways and underground lines as well, when they were built between 1801 and 1921. And we constructed ourselves a number of, over these years, centuries, or over these centuries, networks for horse omnibus and tramway lines. The next item where we have data for our entire study period is so-called rateable value data. Rateable values are assessments of the value of your house, which were carried out over this period every 5 years. Unfortunately, the data has not been preserved every 5 years, but we have data for a number of cross-sections covering the period 1815 to 1921, and we're going to use this data to proxy how expensive different locations are. Yeah, so it's not the price of a house, but it's the value of a house that this data represents. Finally, there's some data that we only have at the end of our, either for sort of, that there are two pieces of data that we only have at the end of our study period, which is the 1921 UK census was a world first by asking a very simple question: ask people, where do you work? And the answer to that question determined the work location, the usual work location of people, and where they've been found on census night, where they've been surveyed on during the census evening. That was their residence location. So we were, for the very first time in the census, see commuting flows between boroughs. Comparable data for the US only becomes available, long into the post-war period. And also most other countries, even the Brits, stopped asking this question in 1831. They didn't quite know what to do with it at the time. So with the commuting data, and because we know where people work, we also for the very first time have employment at the place of work data, so we know how many people work in each location. For earlier years, we don't have any systematic employment data, but we have some data from the City of London that I'm going to show you in a moment. And we also don't have any systematic commuting data before 1921, but there's some data from a firm called Henry Poole Taylors, which I'm going to show you in a second. Okay, so let's have a look at some maps of London. This is the Greater London Authority. So the outer boundaries here are the boundaries of the Greater London Authority. The area in sort of a light blue in the middle is the administrative city of London between 1889 and 1965. So for a substantial part of our study period, that was the administrative city. So we are looking here at an area that's much larger than the administrative city at the time. And right in the middle, almost invisible in light gray, is an area called the City of London, which is essentially the old Roman town. It has this very confusing name, City of London, and it will play an outsized role in what I'm going to show you in a moment. So in 1841, you see a few railway lines down here. This was the very first railway line. By 1841, the railway mania is about to start, and the first few railway lines have been built, branching out in all directions. So I'm going to go in fast forward. I hope the internet doesn't crash through the decades. So this is 1851, 1861, 1871. You see the railway network is growing decade by decade. You see a few red lines popping up here on the 1871 map. That is, these are the first underground lines. So this sort of red circle is today called the Circle Line, but it had a different name at the time. So if I go to 81, 91, 1901, 1911, and 1921, you see that from decade to decade, the network grows. And by 1921, we have a really dense network of railway and underground lines in London. So the kind of shock that we're seeing here is a very large shock. It's not a shock that happens overnight. It's not that sort of in 1836, the Martians kind of dropped railways on London. It's a long drawn out process, the building of the railways, and we'll obviously have to take that into account in interpreting our reduced form evidence and also our modeling. Yeah, but the shock is a large one. We're going from kind of a world without railways to a really dense railway network. That's not dissimilar to what the railway network looks like today. Okay, let me show you a bit of the highlights of the reduced form evidence in this paper. The first thing I'm going to show you is just data. I'm going to show you 2 slides of just data, and then I'm going to show you the results of a difference-in-difference regression, so a graphical representation of a difference-in-difference regression. Okay, so this slide here shows on the right-hand side the population of Greater London, so all of London, the Greater London Authority area today, so the 99 boroughs. You see that over this period, this is an index, so in 1801, the index is equal to 1, and you see that over this period, population in London as a whole grows rapidly. From about 1820s to the 1920s, London is actually the largest city on the planet. It's difficult to believe that that could have been true at some point in the past. There are much bigger cities, obviously, today, but at its time, London was the modern metropolis of this planet. Population in terms of levels grows from about 1 million to about 6 million. So you can also read the index in terms of just millions of people. On the left-hand side is the city of London. So that's this tiny area of about 3 square kilometers, the old Roman city right at the center of the Greater London area. That area experiences a very different population growth over this period. So population is roughly stagnant between 1801 and 1851. Population is around 130,000 people living in the city of London at this, over this period. From 51, you see a sharp decline. Population really just collapses over time. And by 1921, less than 10% of those who were there, or like they're less than the population of the city in 1921 is less than 10% of what the population was prior to 1851, just 70 years earlier. So what we see here is a massive change in specialization. So somehow the city used to be a place where a lot of people lived, and by 1921, that has dramatically changed. The city has lost 90% of its residents. What's happened? Is the city just turned into sort of a ghost area? No. What's happening in the city is a rapid expansion of employment. We kind of know, if you've been to London, you know there are a lot of skyscrapers in the city of London, there are a lot of banks, a lot of law firms and other service, insurance, and other service firms. So what we see here is while the UK didn't produce any employment at workplace counts, the fathers of the City of London were very upset by the fact that the census showed their place as being a total failure that was sort of declining at a frightening speed. And they said, well, you're just counting the wrong thing. You're counting where people live. You should count where people work, and that's here. And so they started their own, what they called a day census. They basically, at lunchtime, counted how many people were in the City of London. And this year, in 1867, in 1881, 91, 1901, and then this finally here is the official census data when the census finally caught up with the City of London and counted employment at workplace, are their day census to measure how many people are working in the City of London. So what we see is a massive expansion of employment in the City of London. Yeah? So we are essentially going over this period from about 130,000 people living in the City of London to about 400,000 people working there, with less than 10% of the original residents still being there. Yeah? So a massive change in specialization that we see over this period. Now the question is, what's happened? Yeah? What's caused that change in specialization? So far I haven't shown you anything about the railways, I've just shown you some time series evidence. Okay, so what I'm going to show you here in the next graph, so in terms of the red lines here, a bit of a red herring, nothing happens really in 1851. The red line just indicates that at that point, the population of the City of London starts declining. Obviously, the first railway is already opened a number of years earlier, in 1836, but as you've seen, the network slowly expands, so this new technology takes some time to really take hold and make a substantial change to what London looks like. Nevertheless, kind of the timing is suggestive that this could be something to do with the railways. So here's one. So we do a couple of things in the paper in terms of reduced form difference and difference regression to tighten the causal link between the arrival of the railways and this massive reorganization in the spatial patterns in London. So what we do here in this, in this graph is we look at parishes, which are even smaller units than boroughs, and we can also construct a consistent parish population, but only between 1801 and 1901. Afterwards, changes in parish boundaries are too massive to get a consistent time series. So each of these dots here is a parish, and what we're going to do for each parish, after taking out some aggregate growth in population for London, is we simply compare the growth rate in population in this parish in the 30 years before that parish gets a railway or underground station to the 30 years after. So it's a simple kind of event study, difference in difference idea, where the treatment is the opening of a railway station, and we're going to compare the 30 years before to the 30 years after. So if you're above 0 here, that means after the arrival of a station, you've grown faster. If you're below 0, that means after the arrival of a station, you have slowed down and your population growth has actually declined. What we see is a very pronounced sort of air wing or airplane kind of shape. We see the red circles here are parishes inside the city of London, so in the very center of London. Some of those decline, these are log population changes, yeah? So these are pretty massive declines. We see that this pattern is not just confined to the city of London, but sort of within about 7 kilometers of the center of London, which we are measuring here very simply with distance to Guildhall, which is a grand old building somewhere in the city of London, as a sort of in a very reduced form way. You see that population basically declines anywhere within the first 7 kilometers. Afterwards, in the area here between 7 kilometers and about 20-25 kilometers, we see massive increases in population in response to the opening of a station. We also have a version of this graph where we go further than 25 kilometers. That takes us outside the GLA, sort of into Essex and Kent and so on. And you see that the effect basically becomes 0. Yeah? So if you're too far away from London, if you get a station, that is not going to make a huge difference to population numbers. But within the commuter belt, getting a station leads to rapid increases in population. Okay, so this difference in difference kind of thing is kind of maybe the closest we can do to establish some causality. Yeah, so if you wanted to believe that this is driven by some omitted variable, you'd have to have an omitted variable that simultaneously causes declines in population in the center after the arrival of a station, and at the same time that variable leads to trigger rises in population in areas that are a bit further out. So it's not that easy to come up with plausible examples. It's a natural experiment, so it's sort of the best we can do in terms of establishing causality, that really what led to this massive reorganization in London is the arrival of the railway. Okay, let me use my sort of remaining 10 to 15 minutes here to talk about the our quantitative model and how we can sort of use this model to learn things from the reduced form evidence that we wouldn't be able to learn without that kind of model. Yeah, so think of questions like, what was the contribution of the railways to aggregate city growth, and so on. Okay, so I'm going to very briefly talk about the model setup. The city consists of a set of n locations. So these locations are going to be here in our data are 99 boroughs, but if you had more smaller spatial scale data, such as parishes or even smaller units, you could also use those as locations. Each location has a finite amount of land, so there's a sort of raw land that can be used. Some of that land, there may be land that's unusable because it's water, for example, or it's been turned into a park. And that usable land can be built on to create floor space. Okay, so locations in the city are connected by a time-varying transport system which determines travel time. So I've shown you my picture of the railway network for the various census decades. And so we're going to take the development of that network into account in computing travel times between each of the 99 boroughs. So it's a 99 by 99 matrix of travel times that changes over time as the railway network expands. Next, the city is embedded in a wider economy which provides some reservation utility U-bar. So workers can decide whether or not to live in the city, and they're only going to do so if living in the city is at least as good as living in the wider economy. And in equilibrium, workers are going to be indifferent between living in the city and the wider economy, sort of a fairly standard assumption. It's a bit like a small open economy model where the city sort of lives in a bigger economy here, the UK and Wales, or the UK, England and Wales, or the UK. So if a worker moves to the city, she chooses a place of residence in the workplace that maximizes her utility, and that choice is going to depend on a number of factors. So let me just, I thought there was a slide that shows the formula, but I avoided that. Let me just summarize. So basically, the decision where to live and where to work is going to be, it's going to be a very real world decision. It's going to depend on how expensive different residences are. Some places are a little more expensive than others. It's going to depend on how nice different residences are. So what the amenity level of these residential locations is. It's going to depend on how long the commute is from your place of residence to your place of work. And which place you're going to commute to in terms of work is going to depend on how much money you earn at each destination. Finally, it's going to depend on some idiosyncratic shocks. Yeah, so you may, for example, have gotten a very good job offer from a particular location in the city, and that's why you've decided, even though it's a very uncomfortable commute, to commute to that location. Or you may live in a particular location because that's close to your family or to other things that you like doing. So there's also sort of this idiosyncratic element which is key to making the model tractable and generating some gravity-style commuting flows in the city. So that's all I'm going to say about the model setup. It's a very simple model. Yeah, both here workers are going to make optimal decisions, and firms, depending on where people decide to commute to employ these people, and firms are here making zero profits and a very simple constant returns activity. Okay, so the quantitative model, we're going to use this quantitative model in two different ways. So the first use that we're going to make of the model is that we're going to combine it with all the historical data that we have and with estimates of how fast the railways are relative to walking, and then use our model to estimate what employment looks like in every location in London. Yeah, so we only observe employment at the place of work in 1921, and we're first going to use our model together with all the historical data and assumptions about the speed of railways to estimate what employment looked like in any year prior to 1921. Second, we're going to use the model for more standard kind of model counterfactuals, where we're going to, for example, remove the railways to see what the impact of removing the railways is on, or sort of viewed the other way around, what the impact of the creation of the railway is on city growth. Yeah, we're going to do this sort of running the model backwards from 1921. We sort of switch off the railways and see how much London shrinks as a result. Okay, so I need to very briefly talk about how fast railways are. So the assumptions about speed that we're going to make are here in the middle of this little table. So there is quite a bit of historical evidence in terms of from historical sources in terms of how fast railways were at the time. So the publication called London Statistics, 1907, for example, has detailed speed data on a number of different railway lines, and both overground and underground. So we're going to assume, based on this data, that the railways travel about at 21 miles per hour. That's including station stops. Yeah, so this is not, you may think that's very slow, that they could be going a little faster. They are going faster, but obviously they need to stop all the time. So the average speed is 21, which is not super dissimilar to what commuter trains reach in terms of speed today. Underground's a little slower at 50 miles per hour, and then omnibuses and trams, are approximately 6 miles per hour. after 1900, early omnibuses are horse-drawn omnibuses, so horses are not that fast, and again, they have to stop all the time. Even electric and later diesel omnibuses from 1900 onwards are not much faster, partly due to speed limits and partly due to congestion. So average travel speeds with these alternative modes is we assume is going to be 6 miles per hour based on the historical evidence. And then finally, we assume that you can walk at about 3 miles per hour. So the key kind of thing to take away here is that the railways are approximately 7 times as fast as walking. Yeah, so once you're on a train, you're traveling at 7 times the speed. So this is not a marginal change in speed, but a real game changer. Okay, what I'm going to show you now is I'm going to show you sort of 3 pictures from the first use of the model, which is sort of using the model to estimate employment in each location in London in any year before 1921. Okay, so the only year where the only location where we actually observe some employment data is the City of London. Yeah, so the solid line up here with the triangles, sorry, I can't do geometry anymore, is the actual data from the day censuses for the City of London. And the dotted line here, dashed line, is the prediction of our model for the City of London. And at the bottom here, this is population, this is also just data here, which we're feeding into the model, how many people live in the City of London and in any other location of London. So the upshot is, what this kind of graph shows is that if you take this model, you take a number of structural parameters that I haven't talked about. If you use plausible values for these structural parameters, then you feed in a change in speed of the kind that I've shown you on the previous slide. So railways being 7 times faster than walking. You basically, the model can capture the stunning change in specialization in the City of London from a place of residence to a place where hardly anyone lives and a lot of people work. Okay, so that's the kind of key takeaway from this graph. So let me show you 2 more graphs from Henry Poole Tailors. So Henry Poole Tailors is a tailoring firm that's been around for a very long time, from before they started in the 1820s. And they're still around today, and they have their office or their showroom and workshop on London Savile Row, which is a famous street for tailors, which is in the borough of Westminster. So Henry Poole Tailors are, I'm sure, very good and very expensive tailors, but the sort of distinguishing feature for our purposes is that they've kept the addresses of their workers, which a lot of firms don't seem to have bothered with. I've spent quite a bit of time in various archives, and it's not easy to find firms that bothered recording and keeping the addresses of their workers. So we observe basically from 1857 onwards, not quite, it would be great to see it even earlier, but that's the earliest data that survived at Henry Poole Tailors. We see how far the workers of Henry Poole Tailors live away from the workshop. And in particular, we observed that at the time they joined the firm. So what we're going to do with this data is we can compare that to the predictions of our model for Westminster. So the dark bars here is Henry Poole Tailors, is the raw data from Henry Poole Tailors, which shows commuting distances of these workers. And this first graph here is for 1857 to 1877. So these are workers that have joined Henry Poole. It's a small firm, so these are a bit of 100 workers. This is sort of the average commuting distance of people who joined the firm between that, and we compare that to the model prediction for 1861. So you see that both in the data and in the model, most people at that point live within 5 kilometers, consistent with commuting being quite difficult still at that point in the early phase of the railway age. Commuting a long distance is difficult, and very few people chose to do so. Yeah? And the model and the data from Henry Poole are very much aligned. If we look at a later period, 1891 to 1911, sorry, I made a typo there, that should be 18, sorry, that's a typo, 1891 to 1911. So the next 20-year period here, again, we see in dark the Henry Poole data. We see that the Henry Poole workers have substantially spread out in this later period. There's still quite a few people. So in terms of the scale, it was nearly 90% living within 5 kilometers of the workshop. Now it's just 50%. So it's the scale is not the same on these two graphs. It's a substantial drop. And you see people living much, much further away and commuting to work a much, much longer distance. As a result, again, we compare that with the model, and it looks like that the predictions of the model line up quite closely. Okay, so the kind of takeaway message that we would like to hear is that this kind of very simple model where people make commuting decisions in a simple but intuitive way seems to be able to capture the substantial transformation that you observe in London over this period. Okay, in a final step, what I'm going to do is I'm going to use this model for some model-based counterfactual, where we can ask counterfactual questions such as, how much did the population of London increase in response to the building of the railways? Yeah, to what extent was what part of the growth of London can be explained by the arrival of the railways? Okay, so the way we're going to do this is always sort of backwards. So we're always going to start in 1921, where we have good commuting data. We're going to estimate our model on the best end of the data, i.e. the end of the data in 1921, and then sort of think backwards and say, what is the effect of removing the railways? In the paper, there are also a number of other experiments, such as only removing parts, for example, the last bits of the railway network. You may think there's some diminishing returns, so maybe the stuff they built in the 1910s and 20s wasn't really worth it anymore, and everything they had before was sort of doing all the work. We could look at just removing the underground network and leaving the overground railways in place. Was the underground worth it in that sense? We also show some cost-benefit, some very simple cost-benefit comparisons for these counterfactuals. So let me show you two results from these counterfactuals. One looks at commuting into the City of London, and the other one at aggregate growth in London. So these counterfactuals are not going to, because we're using the model, we're starting the model in 21 and then removing the railways. We're not necessarily going to exactly replicate, as in the previous exercise, the population in every location. And finally, what I should have said before I show you the pictures, we're going to do these counterfactuals making different assumptions about key structural parameters of the model. And let me show you what that looks like. So the first graph here looks at commuting into the City of London. So from our baseline analysis, we have an estimate of how many people have commuted into the City of London, which is this sort of solid line here at the top. If you, sorry, this is actually wrong. Sorry, there's something went wrong here in the layout. So the solid line down here is commuting into the city in the baseline analysis, and there should be something on here. So there are three different kind of counterfactuals that we're computing for three different assumptions about the structural parameters. Let me explain. So these differences here don't make a big difference, but you'll see on the next slide, they'll make a big difference. So the three things that we can choose in the model is, first, are there any agglomeration forces in the sense of productivity spillovers? So if the workplace density doubles in a location, does that lead to some externalities, to some sort of collective learning of the kind that we have a lot of empirical evidence? So we can either switch this channel off, or we can switch it on and set it to a value that we actually estimate here. We estimate about an 8% density premium, so doubling density increases productivity by about 8%. That comes from this data, but you can also plug in other numbers from other empirical studies if you think that they are more plausible. The second parameter is the question of, are there also some amenity externalities? So if more people live in a location, does that make that location more attractive? Why might that be? Well, as population density increases, the number of things that we all used before COVID, such as cafes, restaurants, shops, and so increases, and these urban amenities, may be quite valuable. So increases in population could increase actually the amenity level of a location. Again, we estimate that that elasticity from the data here in another part of the paper, and there are some earlier estimates in other work that I've done with similar co-authors. These elasticities, these estimates typically turn out to be very large, in the order of sort of 15%. That doubling population in a location, so residential population, increases amenities by about 15%. So again, we can either switch this on or switch it off. The final thing is what we assume about the elasticity of housing supply. So if demand in a location goes up, how much does housing supply increase? Again, we're going to make two assumptions. Either nothing happens, nothing ever gets built in the UK. So if prices go up, there's no extra supply. Or the alternative assumption is that we're going to assume a upward sloping housing supply function, again with an elasticity that is similar to central estimates for other cities, and we've taken from we've produced that from some of the data that we have in this paper. So which of these assumptions you're going to make for this graph doesn't make much of a difference. The bottom line is, if we simulate the removal of the railways decade by decade, commuting flows in the City of London in the model shrink to very small levels, consistent with the railways being absolutely key for the build-up of employment in the City of London. Yeah, so whatever you believe about agglomeration forces in cities and housing supply elasticities doesn't really matter. It looks like that the arrival of the railways was absolutely critical for the expansion of commuting into the City of London and therefore employment in the City of London. In this graph here, I'm showing you a counterfactual for a different outcome of the same counterfactual, saying what is the effect on population. So here, it does make a big difference depending on what you assume. So the very first counterfactual at the bottom, at the top here, says, so down here is the observed change in population in London over that period between 1831, which is just before the arrival of the first railways, in 1921. Up here is the first counterfactual. So if you assume there are no agglomeration forces and housing supply is just fixed, nothing ever changes, then the removal of the railways doesn't explain much of a change in population in London. However, if you turn all of these forces on, so if you believe in agglomeration forces in terms of production, in terms of amenities, and also assume an upward sloping housing supply function, that final thing actually matters a great deal. The model here can explain a large part of the growth in population of London. Obviously, this conclusion rests on a lot more assumptions than the simple reduced form results that we've shown you earlier, but I think that's an interesting result that the building of the railway was really critical in terms of enabling London to grow at a really unprecedented rate over this period. Yeah, so before London started growing in this way, as far as the kind of historical data we have, there's never been a city with more than 1 million inhabitants. Yeah, so London emerging as the modern metropolis is something truly special, and it looks like the railways played a decisive role in enabling that growth. Okay, with that, I would like to conclude and say that, so let me reiterate again that modern metropolitan areas involve immense concentrations of economic activity and the transport of millions of people. That's not happening right now because of COVID, but the results in this paper suggest there are very strong economic reasons why people commute, and it would be surprising if we didn't go back to that equilibrium at some point very soon, once we found a way to safely, travel in an overcrowded underground train again. So we provide evidence on the role of the separation of the workplace and residence for these large metropolitan areas using the invention of the steam railway. We show that our model can quantitatively account for the dramatic changes in the spatial organization of London over this period. And we undertake model counterfactuals to show that the rise of commuting into the City of London can be explained pretty much fully by the model. And we also show that the aggregate growth of London will probably have been driven in a substantial way by the creation of the railways, if you believe in the kind of parameters that I've talked about. So let me stop here and maybe stop sharing my screen, and then we can turn to your questions in a moment. Okay, Georg, maybe you can start.
Yes, do you see the chat on Zoom? So there are two questions in there.
Okay. Okay, so the first question is from Ahmed Bakri to all. Thanks. We see the population curve for London, for London greater area start to decrease again starting from 21. Can you reflect what happened for the numbers after that date? That's a great observation. Yeah, if you look at the time series of London after this period, so London continues to grow after 1921. It reaches a first peak in just before the Second World War, and after the Second World War, London shrinks, loses about 2 million of its population before it sort of turns a corner in the late 70s, early 80s, and about 10 years ago, London has surpassed its pre-war population peak. This post-war dip is not something that you could try and explain it, that transport in London got so bad over this period, for various reasons, that lack of investment and so on, that could explain this downturn. I don't think that would be a very plausible story. Yeah, so there are changes in amenities, there are changes in policies. Yeah, so the kind of immediate post-war period was a period where certainly policy in London was very much opposed to density, and we tried to get people out of London as good as we possibly could. So that might be a more plausible explanation as to why we see that happening at this point, rather than a change in the railways. Yeah? So there are other things that drive city growth other than the railways, but we think that over that period, the railways were one of the key factors for the growth of London. Okay, I hope that is a reasonable answer. So Dimitri asks, a good assumption, but I'm afraid workers do not choose neither their workplace nor their home location optimally. Okay, that may well be the case. So there may be a very interesting kind of behavioral extension of this model where workers or people don't make entirely rational decisions over their location. That would be a fantastic further development. There is probably some evidence that people make behavioral decisions in all sorts of settings. So it may well be the case that people kind of underestimate, for example, how painful a commute is really going to be without having done it for 100 times. Yeah, so we are making here a number of simplifying assumptions. Yeah, so the kind of model here, relative to kind of previous modeling attempts to capture behavior in a two-dimensional city, is kind of makes a lot of progress in terms of providing a tractable framework that makes very intuitive assumptions about how people decide. But it would be a fantastic extension to sort of have a behavioral component and see, we need individual level commuting data really to make progress empirically on that question, to see whether there are particular subsets of the population that predictably make changes. Yeah, there is a paper in the QJE by Ferdinand Rauch and a co-author that I can't remember right now, that has exploited one of the big transport strikes in London, and they basically use individual level data from London Transport to show that some people don't go back to the exact same commute that they did before. So if you see people who've commuted a particular way for a long time, a strike comes along and they basically get pushed into another equilibrium, and they interpret this as some evidence. It's fairly small, it's only about 2% of travelers who permanently change their commuting behavior due to this particular strike, but they interpret this as evidence of some behavioral decision-making, that people maybe just figured out that there was some other commute that was a lot nicer, another way to get to work that was a lot nicer, and they permanently changed their behavior. Sorry, I need to drink something. I've done too much talking. So there are more questions popping on here. Yeah.
The third question.
I can see it. Yeah, sorry, I'm just moving my window around to be able to see better.
Yeah.
Make everything a bit smaller, then I can see even better. So now it's much better. So impressive data on commuters, asked Stefan. I'm wondering to what extent are commuting patterns in textiles representative for other economic activities. So Henry Poole tailors, while they are in textiles, they're in kind of a very special set of textiles. So this is not a kind of textiles sweatshop of the kinds that we have today in other parts of the UK. Obviously, it would be fantastic to have more commuting data from other employers. There is very, very little. So I've looked at a number of archives of companies that go back a long time and could in principle have data. Companies at the time were very concerned with writing down how much they paid you, but they didn't seem to be particularly concerned with where you lived, which is hard to believe. If you work for a modern employer, the first thing they're going to ask you is, where do you live? Yeah, what's your home address? At the time, this was not something that people worried about, and they didn't record that data. The Henry Poole tailors, there is some data on wages. So this data has previously been used by David Green, who actually is an economic historian at King's College, who pointed us to this data and very kindly shared his raw data with us. There is some wage data in there, which is quite sketchy, and it's not, so, you know, it's even smaller sample than the sample that we're using. But from looking at this, these guys are not badly paid. Yeah? So they're not, this is not sort of, you know, minimum wage, not that there was a minimum wage at the time, but this is not minimum wage labor. And these are people, there's some people who paid very little, kind of just shop hands or shop helpers, but some of the very skilled tailors earned pretty good salaries at the time. So one can only hope that on average, these people are reasonably representative of kind of working London at the time, and therefore are good. But if you find some other firm that you know, has great data on commuting that is more representative, or we can sort of get a more representative sample, that would be fantastic, obviously, but it's not something that we've been able to do for this paper. Not for lack of trying. It's not trivial. I'm not sure that there is sort of a golden you know, bullet buried somewhere that one could find, but maybe someone is going to be more successful in finding that data at some point. Okay. There are more questions.
Okay, there is another
popping up here. Yeah, Filippo is asking, did the administrative borders of the City of London change over the long period under analysis? I'm thinking at underestimation of the effect in the difference estimation. Thanks for the really interesting presentation. Thank you very much. No, so we keep the borders of the City of London or all other 99 boroughs constant throughout time. So these boroughs that we're using are the boroughs that were in place between 1889, when the London County Council gets founded, and 1965. So we keep these boundaries constant throughout time. Then, you know, in earlier years, we need to kind of create the population of the City of London. We need to merge together a set of data that comes at the parish level and merge parishes into boroughs. There's going to be a little bit of measurement error involved in that process, but that measurement error should be fairly small, particularly for the City of London. Yeah, so I'm worried about a lot of measurement error in a lot of places here, but I don't think that this is sort of boundary changes should not be a problem. So we hold boundaries fixed completely, but obviously when we, for example, for 1821, if you have to create the population data, these boroughs did not exist in 1821. So we need to basically allocate parishes, which are the smallest unit in which the Cambridge historians have managed to process the UK census data and allocate those to boroughs. But this process, particularly for the City of London, where there's a lot of fine-grained data, should not be a problem over this period. Okay, thanks very much. That sounds very good. Are there any other questions? Maybe some people have commented on the conference platform itself. Not sure whether I'm taking logical questions.
So if there are no other questions, I think we have only 5 minutes remaining. So I would say if there are no other questions, I would like to thank you for the presentation. Okay. Yeah, I would like to thank you for the presentation, and I would like also thank the audience for the questions. And I would say a very interesting model, a very interesting data you presented to us. And I would like to say, if you're interested, maybe a little hint to the next session. The next session is on transport and accessibility too, which is will be led by Professor Wickerman. And so I would say, would like to thank you, Professor Sturm, very much. And hopefully next year we will see you in Bolzano, and not only on internet.